All right. Let's look at question 14. The last time we looked at different kind of questions, we looked at how we're supposed to find the limiting reagent of a certain chemical reaction. We also found out how we're supposed to find the excess reagent in that chemical reaction. So today we want to see how we can get the mass of the product that has been obtained from the reaction between two given reactants. So we've got question 12 here that is saying, consider the reaction below. We've been given iodine oxide here react with carbon monoxide, giving us carbon dioxide plus the iodine gas that we have been given here. And we've been taught to say 80 grams of the iodine oxide reacts with 28 grams of the carbon monoxide. And then they're telling us to say determine the mass of the iodine which could be produced. So we want to find out what amount of the iodine gas was produced after the reaction between the iodine oxide and the carbon monoxide. So how do we go about this question here? I think I stressed much in the previous lesson to state that you have first of all to understand to say a chemical reaction can have a product that is limiting and can have a product that is in excess. And for us to produce the product, it is entirely dependent on the compound that was limiting or the one that was in the limiting state. So I think first of all, before we do anything, we're supposed to find out the product or which one between the two reactants were limited or in the limiting state. So we are going to use that to get us the mass of the iodine gas that was produced. So let's jump into the old procedure here. Okay, so this is the chemical reaction that we've been given. It's the chemical reaction that has been given to us. We're saying iodine oxide, and this is a gas, plus carbon monoxide, which is also a gas here. These reacted to give us carbon dioxide, which is also a gas, plus the iodine gas. And we're looking for the mass of the iodine gas that was produced. And I'm saying for us to get the mass of the iodine gas that was produced, it is entirely dependent on the product, on the reactant that was in the limiting state, or the reactant that was limited. So we first have to find out which one was limited between the iodine oxide and the carbon monoxide. So how do we find out that? We've been given information that we need to use here. Remember, we've been told to say 80.0 grams of iodine oxide was given, and we're also given 28.0 grams of carbon monoxide. So we're given this. So before anything, let's find out the molar mass of the iodine oxide and also find out the molar mass of the carbon monoxide. So there we go. So there's a recommended periodic table that you're supposed to use. So I'll just be very quick so that you know how you're supposed to go about the entire procedure. So this is 15.9994, and then the iodine gas as well. This is 2 times the 126.9045, and then we have here as 79.997, and the other one is 253. That is 2 times 126.9045. We're being given 253.809. And what's the total there? So the total is giving us 333.806 grams per mole as what? As the molar mass of the iodine oxide. So it is very important that we first of all find out the molar mass of the iodine oxide, and we also get the molar mass of the carbon monoxide that is there. So let's also find the molar mass of the carbon monoxide and see what we are going to get from there. So I'll just write it from here so that we can have enough space. So I'm just going to take it as a O from the chemical reaction. From the chemical reaction, it is already balanced here. I've got 2 atoms of iodine, 5 atoms of oxygen. On the other side, 10 atoms of oxygen. On the side of the reactants, 10 atoms of oxygen, 5 atoms of carbon. And on the side of the product, we've got 5 atoms of carbon. So you're supposed to make sure that the chemical reaction is balanced. Please let's not forget that. So we come here and get the mass of the carbon monoxide. Get it as it is in the chemical reaction. And then let us find now. This is 5 times 16 or 15.99. I'll just use 16 so that you know the exact values, but I know you know what you're supposed to do for it to find the molar mass of the carbon monoxide. So this is 5 times 12.01. So you also find the total here. So you find that the molar mass of the carbon monoxide is going to be 140.0505 grams per mole. So this is what we're getting here. So I would love to mention that we've been given the 80 grams of the iodine oxide, and we've been given the 28.0 grams of carbon monoxide, and we just found out the molar masses of these compounds that are here, these gases that have been given here. We just found out the molar masses. We found out the molar mass of the iodine oxide, we have it here, and we also just found out the molar mass of the carbon monoxide, we have it here. So we know to say the 80 grams is the actual mass of the iodine oxide, and it will straight be direct proportion to its molar mass of 333.80 grams per mole. So I'm trying to find out which one was limited, or what was the limiting reagent in this chemical reaction, because what was not enough will determine what was produced in the chemical reaction. If I'm eating something, let's take for instance I'm eating okay, of course, because we are all Zambians here, I mean most of us are Zambians here. I know maybe we can have our people outside the country and people in different parts of the world, the western countries and so on. People eat different kind of foods, but here in Zambia we usually eat in Shema. So the food I'm eating, if I've got inshima and I don't have enough of the inshima, and I've got the radish, so what will happen is the likelihood of me finishing that inshima will entirely be dependent on the amount of inshima that I'm having. If it's less, it means I'll finish quickly. But if it's too much, it means that the outcome will also depend on that. So what point am I trying to emphasize here? I'm trying to emphasize the point to say every product in a chemical reaction is dependent on the limiting reagent. Let's go on to the next step. Okay, so I'll say this was the 80.0 grams, which was equal to the 80.0 grams of the iodine, which is equal to its molar mass of the 333.806 grams per mole. We know this is the molar mass, and we know this is the actual mass. So now let us find the actual mass of the what? I'm going to use 140 here, and you know what to say, the 140.05 grams per mole was the what? Was the molar mass of the carbon monoxide. So I'm trying to find what was the actual mass of the carbon monoxide. that we needed for this chemical reaction to take place. So what was the amount of carbon monoxide that needed to react with the iodine oxide for the chemical reaction to produce what we had in the product. So let us cross multiply there. You're going to have the 333.806 grams per mole. Okay, of course, with the x there, and then that is 80.0 times 140.0505. And when you divide throughout, you discover to say your value of x, or the actual mass. Let me even indicate here to say we're finding the actual mass. What actual mass are we finding here? We are finding the actual mass of the carbon monoxide, because this is the mass of the iodine oxide, a direct proportion to its molar mass. And this is the actual mass of the carbon monoxide that we're trying to find in this chemical reaction, a direct proportion to its molar mass. So I am getting a mass of 33.56 grams. So this is what we needed, or this is what we need. In fact, let me indicate this so that we get to understand what I'm talking about here. So this is 5CO. This is the carbon monoxide. So this is the mass of the carbon monoxide that we need for this chemical reaction to react with the iodine oxide. But what were we given? Let's check what we were given here. We were given to say the mass of the carbon monoxide that we have is 28.0 grams of the carbon monoxide. This is what we were given. They told us to say for this chemical reaction to take place, we only had 28.0 grams of the carbon monoxide. But what do we need? We found out that we need 33.56 grams. This 33.56 grams. This is what we found. We need 33.56 grams. So we can see that what we need is not equal to what we were given. Hence, you can now say that. So I'll say important note here. So hence you know to say this was the limiting reagent. Limiting reagent. And I've always been trying to emphasize the point to say it is through the limiting reagent that you get to find out how much was produced in the products. So this was the limiting reagent. And we move on. So now, since we know this, we can now find out the mass of the iodine. So the mass of the iodine, before we even go any further, let's find the molar mass of it. It is L2. This is how it has been written in the side of the product. So this is 2 times that is 2 times 126.9045, which is now equal to 253.809 grams per mole. This is what we had. And what conversion factor are we going to use here? The conversion factor we're going to use here is very easy as well. We are going to use the conversion factor for the one that was limited, or the one that was in the limiting state for the chemical reaction. So how do we do that? We know to say the one that was limited was the carbon monoxide, and the carbon monoxide had a mass of what? We're given 28.0 grams, equal to its molar mass, which is 140.0505 grams per mole. This is what we're given. So we're trying to find out the actual mass that was produced in this chemical reaction, the actual mass of the iodine that was produced in this chemical reaction. And what we have here, we've got 253 as the molar mass of iodine, 0.809 grams per mole. And boom, we can now cross multiply here, and then to find out the value of x, and then we'll find out that the mass of the iodine that was produced in this chemical reaction was 50.74 grams. So yeah, that is how you're supposed to find the mass of the iodine that was produced in this chemical reaction. It is not much of a complex step. These are not complex steps. These are baby steps, I would say. So let's just learn to practice more and see how level based we can position ourselves. So this is how you're supposed to go about the question. Quite easy, not so difficult. So what important points are we supposed to take away from this lesson? We need to understand to say, for us to get the product, that was in this chemical reaction, the carbon dioxide, the iodine, they are all entirely dependent on the limiting reagent on the side of the on the side of the reactants. So you can check out that, and these are the steps that you need to follow for it to get the mass that was produced in this chemical reaction. So look forward to more solutions to your tutorial sheet, and feel free to consult us whenever you need any questions. Thank you so much. See you in the next video.